Right, so what we're going to cover today is interpreting questions, how to set out answers, tried and tested exam wisdom. And we're going to look at what topics appear for your exam board. I mentioned this yesterday, but the specs sort of changed in 2017. And so it's a lot more uniform now across exam boards. And there are some topics that have been added to the A level. So we kind of feel like they're more likely to appear. And we'll be focusing on that and the language and the style of question. The way the newer papers are different is, we said this yesterday, but more questions that link different topics together. So like we said, the calculus can come up in the kinematics and the mechanics part of the course, but also within pure, there's a lot of overlap and a lot more modeling. So you've probably seen that yourself when you practice the questions, but maths in a sort of context. And also more unstructured calculations where you're sort of not guided through every step. There is still an element of that, but that's been a change as well. Right, a few other new things then. So the newer papers that you'll take basically assume knowledge of the large data set. So that is one key thing for statistics, that for your board, you know what the large data set is based on, what the data is about, and just be familiar with it. There's no sort of, you need to learn loads of data off by heart, more like headings, dates that it was taken, that sort of thing. So knowing the ideas around it. No decision maths and no modules, as you're all aware. Right, so examiner's advice. So some of you, this will look familiar to yesterday, but we're going to go on to some specific year 13 exam technique in a minute. So we're going to look at examiner's comments and really sort of look particularly at the year 13 stuff here. So we need to try and attempt all parts, and you'll be expected by default to simplify answers. Don't leave things unsimplified. And free SF is a general rule of thumb. Okay, so leave your answers to free SF. Actually, for pure maths, I would say in general, just try and leave it exact. So leave it as a third, leave it in terms of pi, unless they say otherwise. So full marks, we need to write any expressions, any variables, and use the correct mathematical notation, not calculator language. So that's really important as well. And then finally, for calculator skills, sometimes using the calculator puts people off a little bit, and they then don't do what they would have done, and they jump steps. So we basically need to be confident in using the calculator. And like I said yesterday, for quadratics, you're only going to get 1 mark for getting the correct solution to a quadratic. So do use your calculator for stuff like that. Right. Again, this will be familiar, but we are going to change this up in a minute. Answer button on your calculator. It does, of course, depend on what calculator you have. Things might be laid out slightly differently. And then basically, you might lose marks if you don't show your work in, where that didn't actually happen at GCSE. You probably got the answer if you got the final mark. But this answer button is key, particularly if you're doing the iterations topic. And sequences and series, that can be quite useful. Right. So a few things now specific to year 13. Sketching inverse functions. Some of the calculators like the CG50 can do this on the graph mode. And knowing the notation is F inverse. Modulus functions. So some of your calculators again can sketch these. Sketching parametric equations is also possible on some of the calculators as well. So any of the graphing calculators will be able to do parametric ones. You have to just change the type of function you input in. I think it says param instead of like Cartesian. So that's possible as well. And then also, as I said, using the answer key, we can do recurrence relations like this. So where you've got UN plus 1 is 2 UN plus 3, and you set U1 as 5, you can, of course, put 5 equals and then just keep pressing in terms of X, or store it as a value and basically do recurrence relations that way. And also, all of the calculators will allow you to do a summation. So for sequences and series, that's really helpful. Okay, so let's move this on. Derivatives at a point, make sure you know how to do that. So they won't do differentiation algebraically. They'll only do it with a value subbed in. So you get the gradient at the point. But even for really difficult derivatives, they'll be able to do that as well. So the trig ones, exponentials, logs, all of it. The one thing I would point out, just remember, particularly as this is a year 13 session today and it's calculus, that you want to be making sure any calculus with trig, you're in radians as the default. So that is important if you're using this setting. Other things it can do, finding the area between two curves from integration, coefficients of binomial expansion. Of course, we know we need to use the calculator for binomial. It's really helpful. It saves us a lot of time. Checking solutions to partial fractions can be good, especially if you go through it this method where you equate coefficients or sub stuff in, use your calculator to check that quickly. Okay, so other specific skills to calculators, quadratic equations involving trigonometry. I can't stress this enough. Do check your answers if you have time in the exam. So put theta back into the original question and check it actually works. Length between two vectors or angle between two vectors. Many of those have a vector mode. 3D vectors are also on there. And also, I mentioned this yesterday, and I am aware this might be tricky on the CG50. So I'm going to try and find out how to do this again. Changing the base for time calculations is great because you can often do this using base 60, and it makes the mechanics problems much easier, and some of the trig modeling ones. Right, variance of a population, normal distribution, inverse normal distribution, and z-tests. Now, this is a major advancement from the old calculators. The fact that the normal distribution is literally, you're able to do it all on the calculator. I would say the big advantage of the CG50 over the class whiz is actually for the binomial tails. You can do the upper tail of a binomial, but the normal distribution, there are 3 different functions there, 2 of which are really useful. The inverse normal is quite a game changer because you can put the area in and work backwards. So it saves us having to standardize everything. So really, really useful that we know how to do that. And we will look at that later. Brilliant. Right, let's keep going. And again, welcome to anyone that's just joined. We're looking at some exam skills, and then we're going to roll this session into looking at trigonometry. So let's have a little look how we're doing. Good. So a few more calculator skills then, if we look at this question here. Integrate on your calculator to save time. We do need to know, though, that we've got to be really careful with a question like this. So notice that it is only 1 mark, but what we have got to do is we would have to do this as separate integrals on the calculator. So think about why, because the question might not guide us through. It says find the total shaded area. It doesn't say find the integral just between -2 and 4. Now, if you integrated this, that would actually be negative. And if you integrated this, this will be a positive area. And if you just integrated the whole thing, that would minus away from that, which in a context like mechanics, if it was displacement, you actually might want that to happen. However, because this says the shaded area, you have to take the modulus of this, you have to turn it positive, and you have to add it to this positive area. So be really careful that you would have to do that as 2 distinct integrals and turn them positive. So hopefully that's clear, but without the diagram, that might be kind of easy to miss. Okay, brilliant. So that's kind of a first thing to point out. Now, the form of the question from command words, we kind of mentioned this a bit yesterday, but I'll just recap this carefully for everyone. So these kind of words here, feel free to add these annotations in. These involve working. So there will be method marks. And if we don't see the method, you will lose marks. So these involve working. These questions that say give, state, or write down, these are usually worth 1 mark. Okay. And plot, sketch, and draw. Obviously, there's slight differences in what we do for each of those. But a sketch, we need to see the key features, the right shape. A plot is where you do like a table of values and dot to dot kind of draw it out. But the sketch is more the A-level skill. And so many people think sketch just means I'll just do a kind of whatever drawing, hasn't got to be to scale. It does still need to be an accurate representation of the curve, right shape, key features, asymptotes, turning points, intersections with axes. So arguably it's more involved than just plotting it without really thinking. And then the explain why, justify, give a reason, and comment on. These are normally follow-up questions in modeling questions and the applied maths. Brilliant. Right. Let's look at a few specific examples. So determine, show detailed reason, fully justify, etc. Working is required often if these are like bigger questions, and you have to kind of pretend the examiner doesn't know anything so that you actually get the marks. So imagine you're explaining it to a friend or something. Right, let's look at an actual question then. So the function f has a domain R, so all the real numbers, and it has a range that y is greater than e. So remember, the domain is for the x values, it's for the inputs, the range is for the y values. And there's a picture of the graph. It says the gradient of the curve at the point xy, so at a generic point, is given by its derivative, dy dx equals x minus 1 e to the x. Find an expression for f of x. Fully justify your answer. 8 marks. Now, arguably, that might be quite generous with marks, but let's go through this together. Just very quickly, I'm going to show you the mark scheme. We will go over these skills later because this is quite a big question, but we'll talk about how the marks are allocated here. So because you're given a derivative and you want the original function and you're told the range and the domain, we are going to need to use integration to go from the derivative to the original function. Now, for first thing in the morning, this is not like the easiest integral to do. So I'm going to just talk this through with you now. This is actually an integration by parts because you've got two different functions that aren't related to each other by their derivative. And this is definitely a big year 13 integration question. So it's by parts. They're not linked as a reverse chain. They've not given you a substitution. So you'd refer to the by parts formula in the formula book. And remember, we set one thing up to differentiate, one thing up to integrate. And so the first thing would be to differentiate x minus 1 and integrate e to the x, and then basically put that in the formula. And up to this stage, if it were out of 8 marks, you'd have 2 already. So you've correctly identified the technique, given the mark for subbing that in efficiently, and then let's keep going. So don't forget the constant of integration at the end once you've fully done it. Now, this is actually really important because there was no plus C in the actual answer. They wanted you to find the actual function. And for a lot of people, they might have thought, well, they didn't give me a point to sub in. They just gave me a picture of the graph. How can I do that? They kind of did give you a point to sub in because they gave you the minimum. They told you that the range was greater than E. So that means the Y value is E at the minimum. This is a really important like problem solving aspect of this question that we could all overlook. This would be really easy for me to miss. We could all miss this quite easily. If I just take you back to the picture of the graph there, that was the most important bit, I would say, of the question, because that does give you a point. That tells you about the lowest point. If you've got a range defined, you're being told where the outputs are capped or where the minimum is. So we're kind of effectively being told this point. So that was what made this a little bit more involved. So if you know it's y at the minimum, the y value at the minimum is e, then we know minimum points, that should be crying out differentiation. That should be when the derivative is equal to 0. And remember, they started by giving us the derivative. So if we set x minus 1 e to the x equal to 0, there's only one solution to that. E to the x can never be equal to 0. So x must be 1. So now we actually have a coordinate that we can explicitly sub in. So this is the coordinate 1, comma e, x value 1, y value e. And again, we've picked up a couple more marks at putting that together. So I would say a mark for kind of identifying this, putting the plus c at that point, and then also getting to this stage here. Now, putting it all together, you've got the equation of the graph with the plus c. You've got an x and a y value to sub in. You can rearrange, and c is equal to 2e. And then basically simplify. Okay, and welcome to anyone else that's joined. We're just going through exam technique, so please don't think that was a really quick go through of integration. We're going to do that all properly again, so don't worry. We're just looking at how like the marks are allocated for this. Brilliant. Okay, right, I'm going to push on to some more command words here. Right, show that. Let's look at this. So show that answer should be sufficiently detailed so that we can follow every step. So like, same for proof, show that and proof. Remember, the answer is given to you. So it's not about like racing towards the answer in as few steps as you can. It's actually almost about maximizing what you showcase, that you actually know how to get from there to there. The examiner knows the answer. We all know the answer. It's in front of us. This is all about method. So this is exactly the kind of question you can't just put into your calculator, because it would be pointless. It will hopefully just give you the answer you already know it should be. So that's a kind of key thing. You can't just put these ones into your calculator. We actually really need to think about the method. Okay, brilliant. So this is a very sort of, I would say, so common now that the questions start with a show that or a prove or a show that this equals to this. So really important. Now let's have a little look at actually this question here. So this show that question. Now you're given the sum, which your calculator can deal with, something like this. But again, it's just going to do it. So we need to think about breaking this up. Now your first mark will be from appreciating that you can split this into two summations. So hopefully we're all familiar with the sigma notation. Now what this is really important in identifying is this little first chunk is actually an arithmetic series, and this one is a geometric. So hopefully you've seen that before, but that will then point us towards the summation for a series that's arithmetic and geometric. And I believe most of them are given in the formula book. I would just say, sorry, this should be R instead of D. I would prefer if we wrote that. You might want to amend that actually in your books, unless that is what it says. So remember, for a geometric, we'd have R. For an arithmetic, we'd have D. But it's the formula you're given or you should know from your formula book for your exam. And this is how we're going to show it explicitly. And the problem with these questions is they do feel tedious because we're actually putting numbers in, writing it all out long ways. But that is unfortunately what they want us to do. So you sub in A as 2, A as 8, and find the first term and find the common difference and the common ratio for those sequences and series there. And then you actually just spell it out with the numbers. So put the numbers in and it should equal what we expect. Okay, brilliant. So that's actually a good one to look at, because I think with the way the technology's progressed and the fact that we can do so much on the calculator now, we don't always make the link with the sigma notation that actually it is just partly an arithmetic and partly a geometric series just put together, which we can deal with if it just said do an arithmetic series. So let's keep going. Some more command words. So we've got explain why, justify, give a reason, comment on. So you'll have a question like this. And I mentioned this yesterday, I think, as well. The examiners have said that the national picture is people are weakest on these questions. And it's annoying because they're not always worth that many marks, but we sort of just throw them away. So you can imagine that this could be a mechanics question, and it will say, right at the last bit, explain the change in motion that the driver noticed. Okay, explain. So a lot of mathematicians do not like that word because they want to do maths. They don't want to start writing an essay. And it is just a short, snappy answer, but it needs to be clear and it needs to be correct, obviously, as well. And there's some funny answers for mechanics where people have just tried to write something and it doesn't make any sense. So what will the driver notice and why? So we really should describe everything that's happened. Let's go back to the question so that we're actually doing this properly. So a buggy is pulling a roller skater in a straight line along a horizontal road. The combined mass is that, driving force and the resistance are given. And so you do this whole question, find the acceleration. Then it says the roller skater releases the rope at point A and she reaches a speed of 6. She continues to move forward, experience the same resistance force. The driver notices a change of motion in the buggy and brings it to rest at a distance of 20 meters from A. Explain the change of motion the driver noticed. Right, let's think about what happened. So the rope's released, meaning the tension isn't there anymore on the buggy. There's no resistance, less resistance to the buggy because there's not someone dragging against it. So the higher resultant force on the buggy will mean there's more force forward. So the driver will actually notice an increase in acceleration. And that's why then the driver has decided to bring it to rest. Okay. So the bringing it to rest, people might think, oh, the driver slows down because she let go. That is not the case at all. The driver's chosen to do that because the buggy's actually sped up. Okay. So do try and think physically what would happen. Right. So there would have been your 2 marks for, I would say, this stage here, mentioning the tension, and then the correct conclusion. Okay, brilliant. Right, let's get on to the plotting ones and look at what we're expecting here. So we spoke a little bit yesterday about sketches, but plots are more accurate using a table of values. Now, it's fantastic that the calculators can help you out, some more than others, with this, but it's the key features you want to preserve and represent and show the examiner. So if, for example, it says sketch the graph of y equals modulus 2x plus a, where a is a positive constant, again, you can use your calculator a bit to help you, but I would say bear in mind the examiners know what your calculators are capable of. So they'll often put an algebraic unknown in the actual graph you've got to sketch, which will make it hard to use. Now, you could still just choose a number and try it out, but this is a sketch. So we want to see the right shape. So the key thing to note is you can sketch this on a graphical calculator and maybe give, oops, sorry, what happened there? Is that still sharing? Yep, okay. Oh no, it's gone a bit weird. Let me sort myself out here. Apologies for that. Can we all see this again? Yes, okay. So you can sketch, oh no. Something keeps happening. I'm going to just stop this for a minute, guys. Apologies. We're right in the flow of things there. Yeah, as I said, this will be possible on your calculator. And if you've got a calculator that does this, try it out right now, but maybe put a number in for A. So choose this and check that you can do it, because this might help you immediately do the sketch. So let me just resume sharing screen. And we'll try and do this together. So something very odd is happening with the pen. And I'm going to try and fix that in 1 minute. Apologies, guys. So just checking we're all on that same page. I'm going to push this on shortly. Let me just reshare it again so we've all got access. Here we go. And we'll have a little look. So moving this forward, let's look at the following. So what we'd have here, 1 mark for the positive shape, and this actually ties in with graph transformations. So whereas y equals 2x plus a in the modulus, because it's in the function, it moves the opposite way in x. So it's going to move across. Now, what you'd have is the 1 mark for the shape, 1 mark for the y-intercept at a, maybe add that on. I would do that, but I don't want to mess it up for a minute. So I'm going to let you just fill that in. The y-intercept up at 0a, and the x-intercept is actually going to be at minus a over 2. And remember, the way to solve that is set the y value as 0, rearrange and solve. And there'd be 1 mark for that as well. Okay, so let's look at a few top tips now for some more year 13 style questions. So we're going to look at small angle approximations. So given that theta is small and measured in radians, use the small angle approximations to find an approximate value of this. Okay, very common year 13 question. I don't remember this being on the course when I did the A-level. I first saw this at university. It's not overly difficult, but it is easy to mess up. So using small angle approximations, it's telling the thing it wants you to use. Now, you probably remember the only dodgy one is the cos one, which obviously this question features. So if theta is small, it kind of ties in with the idea of limits. We're looking at like the net effect of the behavior. So what we should know, and this is basically getting us the first mark, is correctly identifying what the small angle approximations are. So give that stage a tick in your book that that is your first mark. Sine 3 theta is approximately 3 theta, and cos 4 theta is 1 minus 4 theta all squared over 2. Okay. And again, welcome to anyone that's joined. We're just going through exam technique, and then we'll be moving on to some trigonometry. Right. So this is what we're going to get. And then we're going to actually substitute that in really carefully to here. Now, there's something very common in the design of this question that catches people out. And I've been caught out by this plenty of times, where there's already a 1 minus cos of something, and the cos double angle has a 1 minus in it. People just forget to put the extra 1 minus. It's 1 minus, brackets, 1 minus, all of that. Another common mistake, try and anticipate it, is not squaring the 4 as well. It's 4 theta all squared over 2. So there's lots of fractions in fractions. It will tidy up, and we'll get 16 theta squared over 2 all over 6 theta squared. The theta squareds will cancel out, and then your third and final mark is for there. So I'd say the first mark for the top line, the stage where we're about to simplify it, a second mark, and the final mark for the correct answer. Right, so let's keep going. Yeah, cool. So for this one here, we're told that the depth of the water in a harbour on a particular day is modelled by this. So you're given that D is equal to 5 plus 2 sine 30t, and T is the number of hours after midnight. So a boat enters the harbour at 6:30, takes 2 hours to load its cargo, and it requires a depth of water to be at least 3.8. Find the depth of the water, find to the nearest minute the earliest time. Right, so units are really important here. The depth is in meters, and also the time, and we should also be paying attention to AM or PM and all that stuff. Right, so let's have a little look. So this bit here, and depth, so this meters, and then I would say you actually want to give the time. So this comes back to the we want actually in hours, minutes, and seconds. We don't just want 1.21 hours. We have to contextualize that in a minute. So let's have a little look. So 6:30 a.m. These sound like basic things, but it's easy to mess this up. Is 6.5 hours after midnight. Really easy to do that wrong. So that's what we're subbing into the angle. Now from there, what we're going to do is that's going to give us a mark for doing that correctly. If we put 6.5 in, that's actually a mark. Then getting the minimum. And that is, you only get that mark if you put the units. Okay. The next one, setting the minimum, rearranging and solving. So there'll be a mark for this. There'll be a mark for this. And then there'll be an actual mark for solving that. Okay. Now, solving this carefully, we know that there's infinitely many values to that. There's many potential values due to the like infinite repetitions. So we have to look at the domain. We have to look at the restriction. And 8.5, T has to be greater than 8.5 because they can't start loading the cargo till 8:30, which is 8.5 hours after midnight. So we have to solve with that little restriction. And so what we know is the values that will work. The only acceptable one, when we divide by 30 and so on, would be 10.77. Now remember, that's 10.77 hours. That's not that handy. So we want to convert that to a time using base 60. So if you've got like the class whiz or the older calculators, you'd write 10.77 and then you could use this button, which will turn it into 10.46 as a time. If you're doing it an old-fashioned way or you're using a different calculator and you can't find that button, then you can just keep dividing, find like 0.77 of 60, and then you get it in minutes, and then you can do it for seconds. But we want it to the nearest minute. And also note that we'll say AM. Make sure it's clear what time of day. So these are one of the modeling in context questions. Brilliant. Right, a few other little points, and then I think we'll take like a 5-minute break, and then we'll be ready to move into the trigonometry, which is going to be quite a full-on session. Again, welcome to anyone that's joined. Let's keep going. So a few things to point out, just depending on your exam board, there are different formulae and different things that you have access to. Go on either your school website or your exam board's website and make sure you're 100% familiar with what they give you, because if there is anything missing that you need to commit to memory, it's probably worth like doing that now. So don't leave it too late, but just be like, okay, if I don't need to remember all of these integrals, but it's handy to know some of them, or just know that they're a thing and know that they're in my formula book. Right. Basic recap of trig. We should know all of this stuff. And from year 12, we should know the two main identities, that tan is sine over cos, sine squared plus cos squared is 1, because off the back of those, we have some new identities in year 13. We have 1 plus tan squared is sec squared, 1 plus cot squared is cosec squared. So these lead us to some new identities as well. Right, so new identities. I'm going to add those in. And 1 plus cot squared theta, which you can derive from the year 12 one, but they're handy to know as well. Okay, brilliant. So let's keep going. Considering the units now, just top tips for mechanics. I did also say this yesterday, but I want to really, really reiterate this. I can't stress enough for mechanics how much the force diagrams are important, especially on slopes. Just take up as much space as you need. Don't do a little scrawly little drawing, make it really big, because mechanics is tough to visualize. So do draw it nice and big, nice and clear. Let's keep going. So the large data set, as I said, the main things you want to know or be familiar with are like the headings, the units, especially the weird units, the uncommon ones, limitations, anything that's missing, and any context that might be really, really important to refer to. As I said, you don't need to like learn values off by heart. So most of the large data sets, you go on your exam board website, there'll be some information about it as well. So maybe focus more on that.